Yeah, today we'll be discussing about um, introduction to Web3. So, first of all, I would like to introduce myself again. I know she has introduced me. I'm Damilola Ogungbesan. I'm a software developer at Webster, and also blockchain. I'm involved in the blockchain development as well. I'm based here in Lagos, Nigeria. Could you please go to the next slide? Um, so yeah, I'm based here in Nigeria. Well, I have some. Well, when I'm not working, these are the things I enjoy watching TV series, movies, and the typical things that I don't know if you're a fanboy like me of video games. So yeah, without much ado, let's get into it. I hope we'll all have fun. So yeah, here are the outlines of what we are going to be talking about today. About in actually getting to dive into Web3. So we'll talk about the evolution of the web. Um, what is Web3 itself? What is blockchain? Why blockchain? Right? The different types of blockchain network that we have. Right? The value of it. Um, how you can start developing um, for Web3 if this piques your interest. Without beyond development, how else can you be involved? And also, I created a very short list of resources of how you can actually start learning for free, right? So, yeah. However, before we proceed, I need to make a quick disclaimer about what this talk is not going to be about. We are not going to be talking about. I know Web3 conversation has like different kind of sphere. Today, what we are going to be focusing on is more of like understanding how these things come together and why they are the way they are, what effect they are exactly having on the global economy, if you will, and on we day-to-day users, right? So, without further ado, let's jump right in. So, Jenna, please, next slide. Excuse me. So, yeah, the evolution of the web, right? Like we know, we are saying Web3, right? Which means there has been some, it's a descendant of some previous version of the web, right? If you will. And so we've had Web 1.0, we've had Web 2, which is what we are very conversant about today, which is currently what we understand the internet to be, right? As of today majorly, right? Then now the new evolution of it is what 3.0, right? Where we get to understand about blockchain and the like. So next slide. Um, Web 1.0 um, was pretty much, in the early 90s when internet became a thing that, everyone was, not everyone, when like internet was just coming to the surface, back then it was more of like the nerdy people that they literally just characterized knowing anything about it, right? And back then it was more of, you know, someone just some nerdy computer guy, have like so much knowledge about computer stuff and probably wants to be writing a blog post or whatnot, right? Putting up content. And they typically manage all of these things themselves. And there was not really much, right? It was just some basic random text. Well, not random, some basic text, right? That's just to share knowledge or information or whatnot, right? So there was no way of there was no interaction basically, right? You could just feel. So you can think of it as a read-only mode, right? Of the web, right? Moving on, next slide. Then now we are in our current generation now. At the point where we are in with the internet now, we are basically in Web 2, right? The second iteration of the web. This we've been seeing this from the early, far back as like 2004, right, till date, right? In the early days of it, it was not as easy as it is currently now, right? You can literally send anybody anything like messages. We can do a lot by just tapping a button, right? Today, right? That's how much how far we've come with Web2. However, everything comes with its own challenges, right? Now, because of Web2, Web2 gave rise to platforms, a lot of platform and services, right? And these platforms and services were, of course, to make our life much more easier in terms of giving feedback, where going beyond just read-only mode, right? Where you can consume content, you can also like create content with ease, right? I mean, you can just think about how easy it is for you to be a video content creator now. It's just like at the click a button away on YouTube now, you can upload videos and it's just as easy as that now. However, this comes with some drawbacks, such as like we now have to giving up um, centralized body, right? By body, I mean the owner of this platform. So much power with data, right? Our data, and we don't get to say what they do with it or how they use it, or we don't get to even to even know how much of the data they are even collecting to even begin with, right? And you might think this is no big deal, but imagine you come from a country where um, um, some I mean some country where yeah, we say freedom of speech, but then in that part of the world, freedom of speech is not exactly freedom of speech, right? And a company or a business there happens to be a partner with one of these services that you use, and they already bought random data, right? And of course, because geographically, you will be part of the people that your data gets sold to them for whatever reasons, right? And this can blow back at you, right? And essentially, Web2 gave to the power of censorship and centralization of all of this um, power becoming somewhat monopolistic, right? Think of the likes of your Google, Facebook. We've seen so many security scandals over and over because of, well, too much power, right? In a way. Next slide. Now we've come to the era of Web3, right? What this brought to us is decentralization, right? Trustless, token-based, peer-to-peer connection, right, of nodes, right, on the blockchain. We are going to go a bit deeper about what all of these that I've mentioned here are, right? I know sometimes they might be like buzzword, but don't worry, we are going to discuss them. Decentralized in the sense that, oh, sorry, decentralized in the sense that now, like you said, Web2 is about, a lot about centralization of data, right? Now, no one controls it, right? Everything is decentralized in a peer-to-peer manner, which means um, I'm here in Nigeria. I can probably be running a node, and also, I think you're from South Africa. I'm just making a random assumption here, in case you're not. Apologies. Can be running his own node. True, excellent. Yeah, be running his own node in South Africa there, right? Essentially, what happens is he does not really have to know me or even trust me, but he knows that because I'm not the only one and he's not the only one running this thing. And so whatever record he sees there should be valid, right? Next slide. And this brings us to the concept of blockchain. I mean, it's like a misconception a lot that when people hear blockchain, they kind of blockchain is not cryptocurrency, right? But cryptocurrency is a subset of use case of what blockchain is all about, right? Just to see it. And so you would ask me, I mean, what is blockchain then, right? Next slide, please. Um, what is blockchain? Blockchain is a distributed, immutable ledger linked together using cryptography, right? And they are managed in a peer-to-peer connection of nodes, right, on a network, right? By network here, I'm referring to a blockchain network, right? It's distributed. Like I just gave an example earlier that Umbuso and myself and thousands of other people around the globe, right, in different geographical location. And interestingly, this geographical location could be strategic, at least not that the network, people that run the network actually know. Because if someone is living in Iceland, another person in, say, in Spain, in Portugal, and we are running, say, a Bitcoin node, right? Um, we all don't even know who is running it and how many of us. I mean, we can know how many nodes that are actively running, but not necessarily knowing who is the person running. I mean, it could be a monkey somewhere in the Amazon, right, running it, right. No one cares. What we do know is the code is always right. Okay, so because it's in a peer-to-peer, immutable in the sense that once any record goes onto the blockchain, right, it can be changed for life, right, and because this can be, I mean, you can actually literally replay the flow, right, of the existence of any blockchain for that matter, right? We will talk about some other different types of blockchains that we have very soon, right? But take for instance a Bitcoin node, a Bitcoin node blockchain, right? We could literally see the first transaction from the first transaction that ever existed, right? Which typically it is called the Genesis block, right, that ever existed on Bitcoin from, I mean, that's far back as 2009, right, till date. And we can be confident that every record that we read on that blockchain is exact and like it is correct. Like you can be confident that it has not ever been tampered with, right? And these are run by various nodes. So a node typically is just it's like it's a machine, right? Connected to the network, right? They all store copies of the blockchain and share information with other machines. Machine essentially is just a computer, all right? And this is pretty much like the example I made earlier. Like Busso is running a network, a node of the network. I'm running one. You see everybody on this event, or right now we are all running one node of our own um, choice, or even multiple nodes, right? As we so please, right? And all of these nodes are going to be they will be connected together, right, in a peer-to-peer manner, which means every record that exists on my node exists on Chiama's node, on Osana's node, on Mbuso's node, and every other node as such. All right. Next slide, please. So this is typically how the we can just visualize how this distribution, decentralized ledger that we are talking about looks like. Now, excuse me. So we can see internet a very big. Well, we don't even know how big it is, but we know it's quite big, right? We have all of us here, right, as nodes that we are running, and we are keeping. Remember, we all have the same record of it, and this record is the ledger, right? Is the ledger of the blockchain, right? So if anyone, say Alice in this case, needs to send any kind of information to Bob, right? That means that information has to go through all of us here, right, into something called a block, right? Next slide, please. So because this is how the blockchain works. Data are grouped together, right? The block, right? And each block, right, it has its own size limit, right? And when the block is filled, right, it will be changed to the previous block in the chain, right? I know that's a tongue twister, but I mean that's how we arrived at the word blockchain. So it essentially what that means is that I think let's explain what a block is, then I will explain this. So a block is a data structure, right, that records transaction of data permanently in form of hash, right, by using some hash function. It records this data on the blockchain, right, and each of these blocks contains a cryptographic hash of the previous block, a timestamp, and the transaction data. right? And this is how you could literally store anything, anything whatsoever, right, on the blockchain, because you are not exactly storing. So suppose you wanted to store a video file, right? So you're not exactly putting the video file directly on the blockchain. What you are doing essentially is this video file gets passed through an hash function, right? Turns that video file into like an hash, right? This is beyond this scope of what we need to talk about, but we can just talk about it briefly. Although the file itself needs to be retrieved from somewhere, right? But it has been turned into a hash, right? You know that Osana did upload this video, right? All of those record is already in that hash, and then this hash, right, becomes part of a block. All right. Now, this block now, like you said, a block has it has its own size limit, right? And before when it's filled up, right, that's when it goes into the chain. What we are saying here is that when this block is getting built, right? Different blockchain have like different block size limits, all right? And this is how before this block gets formed, there is something that needs to be done, which is like a consensus, right, to validate, like that diagram I showed you earlier, where all of us need to have the same record, right? That means Alice wanted to say something to Bob, right? It goes through my node, goes through Buso's node, goes through Busana's node, and everyone else's node, right? Essentially, all of us have validated that yes, the record that is coming in here, we've agreed that yeah, this thing is valid because it must have, of course, it must have gone through some tests called consensus. Um, it's allowed to be a valid block, right? Then it gets packed into that block. Now, until that block gets filled to its designated size, right? Until then, it's still going to keep accepting new data, right? But once you get to the limit of it, right? Take for instance, Bitcoin has a block size of 1 megabyte, right? And a block time of 10 minutes, right? What that means is it will take 10 minutes for one block to get filled, and that means until that's why you see that I know you may have heard that Bitcoin is kind of slow because in terms of like volume of transaction that can be processed, right? That means it will take 10 minutes for it to even get added into the blockchain in the first place, and until it does that, which is when you need like you said, the block will contain the previous block information, right? Timestamp and the data of this new block before it can be verified that okay, yes, this is actually a valid block, and then get into the blockchain. All right. Excuse me. And that's how this block is being formed. Next slide, please. So this is you can visualize a block like this, right? Typically, you get new data, new data. You can see this bar on that, like that's just to show like this threshold, like if it's filled or not. By the time it's filled, it gets changed to the previous one and the next and the next, and the list goes on and until infinity. All right. Next slide, please. So, like I mentioned, this for a block to get added into the blockchain, right? There's something called consensus, right? There are different types of it. We have consensus. It's called a consensus algorithm, and what that means simply is that it's how we the nodes, right? Various nodes, because remember we said blockchain is trustless, right? So it's not just about excuse me, I have added this. My record are valid. Yes, you can trust me. No, we don't trust you. We trust the code, right? So when the consensus algorithm, there are several types of it, right? Which is how, like I defined here, it said a consensus algorithm is a mechanism that allows users or machines to coordinate in a distributed setting. Remember our definition for blockchain: it's a distributed, right, immutable ledger, right? So this is why this consensus is being used, and there are different types of it, right? And the reason for this is because it provides the ability for fault tolerance. What that means is that now, regardless how you try to like attack the network, right? So far, you don't have like 1% of the network. That attack will surely and always fail, right? If you don't have the 51% of the total node that exists on that particular network, um, by the help of consensus algorithm, different types of it. We have the proof of work, proof of stake, proof of authority. There are several other ones like for history and the likes, right? If you don't have 51% of it, it's definitely going to fail, right? And that particular node that tried to rip off the entire network will be punished, right? So moving on. Next slide, please. So there are different types of blockchain. We have the public blockchain, we have the private or managed blockchain, we have consortiums, and we have hybrids, right? So public blockchain essentially is what a lot of us are very much familiar with, the likes of Bitcoin, Ethereum, Litecoin, Cardano, Solana, Polkadot, and a lot much more of them like that, right? And how do we know? They are permissionless, right? Because the nature of blockchain naturally is permissionless, open, right? That means anyone can join. That's why also in South Africa can just spin up a node of his own and join the network, and he's guaranteed that even though it's a fresh node, he's going to get all the history data from the day, from the first record to date on his own node as well at any time he joins the network. All right. It's completely decentralized. All nodes of the blockchain have equal right and access to do, creating a block, validating it, right? And yeah, like I said, we have several ones. We've seen them work as it is now, like Bitcoin, Ethereum, and the likes, right? We have the private or managed blockchain. They are permission, right? That is the difference between them. These are mostly used like corporate bodies. They also want to benefit the value that blockchain provides. However, it's not a democracy over there in corporate world, right? So somebody has to be like a gatekeeper, right? It's permission. Nodes have to be invited, right, by a central authority, right? And nodes are not guaranteed; they are not granted equal rights to perform functions. So some set of nodes could be permitted to be allowed to create blocks. Some could be allowed to be validators of those blocks, right? And of course, that clearly just means they are not fully decentralized, right? So moving on. An example of that is Ripple and Hyperledger, right? So Ripple, I don't know if you've heard of Ripple, but I'm pretty sure a lot of us might have heard of the token called XRP. That's like so when you hear XRP, they're technically talking about the token that powers the Ripple network, right? So it's like business to business kind of network, blockchain network. This next slide. So we have the consortiums, right? So they are also permissioned, right? And they are governed by a group of organizations rather than one entity in like the permissioned ones. And this is mostly because the use case for them are way much more, they are security intense, right? You can think of the likes of, I mean, some enterprise level of security kind of stuff, right? So this is why some businesses, and this is not something that anyone can just run. These are like big organizations trying to benefit from the blockchain. They come together and they set the rule of the game, but it still works like as a blockchain, just that they still kind of be the gatekeeper to some degree. Excuse me, guys. So an hybrid, that's pretty much trying to benefit both public and private type of system of the blockchain, right? And use case for this one, they are vast. If you have something like you're trying to do like a supply chain and the likes, right? An example of that is the IBM Food Trust, right? It's a supply chain type of dedicated for supply chain. use cases, right? Built on the blockchain as well. Next slide, please. So today we are most of the things that we are talking about is mostly pretty much about public, right? The public blockchain. But we just wanted to mention just for at least for knowledge sake of other of it that other type of blockchain methods that are possible that are available out there, right? So what are the value that blockchain provides, right? Like we mentioned, immutability, right? Once a transaction is passed into a block and confirmed into the blockchain, it cannot change forever. So which means you can always replay, right? You can replay all the steps, right? And see at what point change, right? When did this person did what, all right? So it brings about immutability. Today in the normal too, some guy that has a PB admin access could easily go and change with SQL code, even though on the application level you cannot do that, right? So we cannot exactly say it's completely immutable, right? But on the blockchain, that can never happen because it means you would have to change for all the nodes that have been existing, the one that are existing, the one that will exist as well. Right? And trust me, economically, you are getting, it's almost impossible, right? Um, Nearly impossible, actually. Well, anyways, so we have security, right? Due to this decentralized nature of it and cryptographic encryption, it is very secure, right? Like I said, for you to bring down a blockchain network, you would have to own 51% of it, right? And I'm pretty sure you. I don't think anyone can do that yet. As far as we know right now, it's quite difficult, right? So, that it goes beyond just technical skills. It means like you have to be diplomatic to tell people to come and join you just to bring down the network that they're benefiting from. Remember, we mentioned that blockchain has a token-based economic model, right? Which means you are not just running node for running its sake. You are running this node and keeping it alive, and you get as you run it, and you are supposed to be a validator or a miner, right? You get some token of crypto in return, right? Technique for sustaining yourself and the node to keep running. More or less like incentivizing you to make sure that you are a fair player, right? So I'm pretty sure it will take you a lot to convince everybody to not be a fair player, right? So authenticity. That's a tongue twister. So due to the immutable nature of it, right, records from the blockchain are guaranteed to be tampered with. We've mentioned this again and again, and that means anytime you record, if you can read any blockchain of your choice, if you can go and read the transaction history of the blocks, um, you can be guaranteed that yes, everything you're reading here is valid. If they said someone moved somebody's money, say in cryptocurrency, which is something that we hear a lot, the person definitely did it, right? You cannot say you did not because the record shows that you did, right? It brings about that kind of level of authenticity. And leading me to the next point of transparency, anyone can actually literally go and do this thing, right? Because of it's how transparent it is, right? It brings about transparency. Anyone can do transaction of the entire history at any time, at will, right? So these are part of the things that blockchain provides for us. Next, please. Next slide, please. Yeah, let's make some public blockchain network, Bitcoin, Ethereum, Cardano, Polkadot, Solana, right? All of these, they are a good example of public blockchain network. Right? There are several other ones. And what this means is that any one of us here can decide to start running our own node at any time. So far, you can meet the minimum requirement of what it needs to run any of these nodes, right? Next slide, please. Next slide, please. All right. So, no, go back one step. Previous one, yeah. Thank you. So, no, okay, yeah, that's it. So, Bitcoin and other programmable blockchain, and this is how what we are trying to understand when it comes to Web3. It's all about it goes beyond just cryptocurrency. At this point now, we've been able to come far to um, program our own blockchain solutions on, riding on other blockchains, right? And that's how we come about the other programmable blockchains, right? So, because by design, Bitcoin was designed for just providing an alternative traditional finance, right? Which means pretty much dealing about all about money, right? Now you can literally send someone money in China without having to pay, excuse me, enormous fees, right? Or, to so many redundant third party players that literally what they are all doing is quite redundant, right? At cheaper rates, right? That was the primary design of what Bitcoin is meant for, right? And now from Ethereum, Ethereum took it a step further, right? By providing like a programmable blockchain, right? That has given rise to building solution or other important solution, right? It leveraged blockchain for building solutions such as well. I know we've all heard the buzzword decentralized application, also known as DApps or DApps, as some people call it, right? That's all are possible because of what we call smart contracts, right? And Ethereum has its own smart contracts. By sorry, is someone talking? Okay. Ethereum has its own smart contract by building on using a DSL, right, a domain specific language. That's called Solidity, right? So what that means, if you learn how to write Solidity today, you can start deploying your own smart contract, your own um, decentralized apps or dApps on the Ethereum blockchain network. Next slide, please. So you might be wondering, what are smart contracts, right? Smart contracts are is an application or a program that runs on a blockchain. Typically, they work as digital agreements, right? That is enforced by a specific set of rules, right? That what that means is, if Kosana told me that, all right, Dami, if you were gonna buy my car today, if you provide me so and so, you can come and take my car tomorrow. All right. You know, he's human as well, right? So tomorrow could come and I'll do everything, and then he'll say, all right, yeah, you did, but I forgot you're supposed to add this to it, and dispute, right? But if we add a smart contract that says, okay, yeah, that means if you do all this, tomorrow the car is yours, right? And remember, this will be digitally signed and based on the blockchain, right? That means come tomorrow after I've fulfilled all the requirements. He cannot say he didn't say that again, right? And clearly, I own his car from there. So, and if I did not otherwise, right, as well, that means I can't come to claim the car, right? That's just that's why the saying that you say the code is valid, like the code. Let's put it in code, right? Contract should be in code, right? That's what brought about the idea of smart contracts, right? Different type of blockchain have like different type of smart contract way of how they write their smart contracts. Ethereum is like one of the most popular one, and that's by using Solidity. Solana, which is a Rust-based language blockchain network, right? So you can write your own smart contract by writing some Rust code, right, to make that happen. Excuse me. So essentially, what that mean, what's going to happen eventually is, because it's all about trade-offs, right? What benefit does Ethereum provide me that Solana doesn't, or does Avalanche does not provide me? You know, the likes of those, right? So yeah, that's how you actually like write your own programs on the blockchain. Next slide, please. So we'll talk about use cases like in our day-to-day use case of blockchain, essentially talking about Web3, Now, the most common one that we all know is cryptocurrency, right? We have um, decentralized finance, DeFi. We have NFT, which is like the buzzword, cool kids on the block these days. We have DAOs, decentralized autonomous organizations. All right, next slide. So we are going to be talking about this in detail now. Cryptocurrency, or crypto, as a lot of us call it, is a digital currency designed to work as a medium of exchange through a computer network that is not reliant on any central authority. Excuse me. Please go back. So what that means essentially for us is that, now you could own, any of us could own any crypto of our choice, right? Without having to worry about, okay, um, uh, without even worrying about the how, it's just about buy, right? Imagine if you wanted some dollar, and it's digital, right? So you don't have to you don't need to keep it in hand, right? Imagine you wanted to buy dollar or pounds, and that's not your country's denomination, right? What do? You go to the bank or some guy that knows how, that has that particular currency, and then you buy, and you guys just swapping, blah blah blah, But and cryptocurrency in itself has an intrinsic value, right? Which means it grows in value. I mean, you wonder, like they said, Bitcoin is digital. How come it's worth tens of thousands of dollars overnight, right? It has an intrinsic value. What does that mean? What that means is that now, as you might know, Bitcoin is a deflationary. It's to help with, as against inflation, right? Now, the benefit of that for the masses is, like, it already has its own intrinsic value. That's why you get some random news, maybe not so random, happen, and then you hear, wow, Bitcoin is the price of Bitcoin is going down or it's going up, all right, because of its own intrinsic nature of value. Next slide, please. We have DeFi, decentralized finance, right? Decentralized finance may is referred to the movement, right, that aims to create open source, permissionless, and transparent financial services, right? Financial service ecosystem that is available to everyone, right, and operate without any central authority, right? Now, and it says that the user would maintain full control over the asset and interact with the ecosystem through peer-to-peer and decentralized application. All right. So enough of all of those. So what DeFi is bringing to us is, now, just like you say, it's decentralized, right? That means it is not region based. Now, I'm a Nigerian. I'm based in Nigeria. Suppose I heard of some nice development in, say, South Africa or Mozambique, and I said, okay, but right now the way the financial system is set up, for me to access any of those two regions, I must be a Mozambique citizen or a South African citizen, neither of which I'm not. That means, and say my country does not provide that kind of service for me, or does not offer that kind of juicy service that is making me crave, like, wow, I wish I was a South African. All right. So in that case, it's limited. That's the problem we have in our current financial situation, in financial service as of today. But with DeFi, what that would mean is, all I have to do is, by using my wallet, my crypto wallet, right, connect that to some D app, right, some dApps that provide a DeFi service, and I can start making loans, or even providing funds to loan to other people, right? But remember, I'm here in Nigeria. I can be doing the same to someone in the United States or someone in Iraq, you know, and a whole lot of financial services as such. Like, literally everything that you can think about financial services today, right? Be it loan, mortgage, whatnot, right, can be provided through DeFi, right? And the sweet spot of it is that it is decentralized, right? It is not region based. You don't have to be a citizen of that country to partake, even though the people that launch that dApp or solution are, say, Mozambique or South African or Nigeria. You don't have to be any of those citizens, country citizens, for you to partake and benefit from it, right? So That's the stuff that DeFi has brought to us. However, I mean, with great power.
Hey, Dami, can you hear me?
Next slide, please.
Dami, can you hear me?
Okay, I will continue. So some of the drawbacks are poor user experience, right? You cannot think about using DeFi apps today is not yet as seamless as it is if you wanted to borrow on like your normal bank apps or some random fintech app, right? Like you have to go through like connecting your wallet, all of those kind of stuff, and it's the blockchain, right? Which means you expect it to be somewhat not as fast as just sending a video on Instagram, right? So you know, um, it still has like that kind of laggy user experience and sometimes poor performance, based on blockchain. Even if you've never had to do it, you must have heard people say something like, "Man, Ethereum gas price is killing." I imagine you want to send $100 and you have to, and you have to spend. Say you even want to send $50 and you have to pay almost $100 to send it. I mean, that just makes no sense, right? So yeah, it can have some poor performance as well. And one of the biggest risks is the risk of user error because you literally are in charge of your own assets, right? You are in charge of your money. You are your gatekeeper. So if you lose your keys or you lose your wallet by some accident and you cannot retrieve it, I'm sorry, my friend, well, your money is gone, right? Or your assets are gone, right? So we still a bit far away from providing that guarantee that you get from like centralized finance of what we know it of as of today, right? So next slide, please. So we are now moving on to NFT, non-fungible token, right? NFTs are, non-interchangeable, right? Unit of data stored on blockchain. It is a form of digital ledger that can be sold or traded. Well, and as far as we know of it today, it is mostly in form of digital files such as photos, videos and audios, right? So I'm sure at one point, so every one of us has heard about NFT buzz and craze that is going on everywhere. NFT this, NFT that. So what NFT is simply is like you can literally take anything, literally anything, picture, whatever, and snap it and call it an NFT, pretty much, right? But the use case of it are like still quite, yeah, not fully nurtured yet. I'm sure you may or may not have heard of Metaverse, right? And this is like very good spot. It's a 3D world of digital space, like bringing the real world that we live in now into the digital space. And a lot of the things that you'll be seeing there are pretty much art, right? Digital art that you see. And that there comes some nice use cases for NFTs, right? Imagine you own an NFT of the Times Square, right? And you bring it into the metaverse, right? You will be as rich as someone, you might just be as rich as whoever owns Times Square, right? But I mean, that's by the way. But yeah, those are some of the possible use cases of NFTs, right? Moving on, please. Next slide. I'm gonna be pacing a bit. Time is fast spent. So we have decentralized autonomous organization DAO, right? This is actually a very, very good one. One very interesting use case of blockchain, right? It's also having some buzz lately. And what it's pretty much DAOs are organization represented by rules encoded as computer code. Remember, smart contract, right? It is transparent, controlled by the organization members, and not influenced by central government. In other words, they are member-owned communities without centralized leadership. Now, what does this mean? Now, these days, right, we have a lot of organizations. Think of like your VCs, right, and the likes. what DAO
Mm.
is pretty much bringing to
Go
the
to
table
Jenna.
here is
Go
like
to Jenna.
we could all come together and say, okay, we want to do this. We are for this purpose,
Jenna.
right? We create tokens, right? And based
You
on the
see,
quantity
I
of
click
tokens
on
that you
that thing
have,
on the channel.
that gives you a different level of voting power, right? We decide what needs to happen, how it has to happen, who does what, when, right? But it's not like some kind of dictatorship where somebody wakes up and says, "Yeah, this is the direction we are going." You have to put it to a vote, right? Now, some other interesting use cases for it, like I mentioned earlier, currently the way we know of VCs, if you venture capitalists, right? What they do is like help some businesses raise funds and whatnot. Now, there are some DAOs that are for that purpose these days, right? They have the funds and they, based on project and this is not a matter of, okay, yeah, my friend brought in and I think, yeah, their project makes sense. Even maybe when it's not really, right? And then you throw money at their back. You bring that kind of conversation to the table and there's a vote, right? And everything that is done on DAO is community based, is community led, right? Voting rights, voting power, right? Pretty much you are bringing power to the people, that kind of stuff. So yeah, that's what DAOs are. Some examples are maker DAOs. I don't know if you heard of DAI. It's a stable coin pegged against the dollar. Excuse me, guys. Pegged against the dollar. So they created that, right? We have Uniswap. Uniswap ordinarily is a decentralized exchange, but for things to happen there, it has its own DAO for voting and rights, same as A, right? These are like some popular use cases of the blockchain, right? And this is how everything you've heard about, like Web3, this is practically all of them falls in one of all of these categories. Either you are doing a cryptocurrency or you are building an NFT marketplace or not, or an NFT collection of its own, and backed by some kind of DAO, right? And some are actually just building infrastructure to support these, right? Next slide, please. And that's how it's been going as far as we know it. Now, you might be thinking, okay, yeah, Dami, yeah, I think this thing makes sense to me, and okay, what can I do? How can I start getting involved in this stuff? Yeah, that's what we are here for, right? How to be involved. We've been introduced to it now. We have some knowledge of it now. Now, how do we get involved? Right, the blockchain ecosystem essentially is still quite relatively, right? It's still relatively new. It's still in its early stage because there's a lot that needs to be built, at least to meet the standard of what Web2 is currently, right? Today we can, in Web2, you can open up your Instagram and start live streaming, all right? Because some central server, some central body own all the infrastructure, they can control of these stuff. You can compare that to doing that with Web3. Oh my God, that's gonna be some serious pain, you know. Um, so we still have a very, very long way to go in terms of scaling Web3. So this is how you could contribute to your own quota and get involved. You can become an open source contributor to any of those blockchain networks and even other ones that have not been listed that you can explore on your own, right? Um, you can get into blockchain development itself, right? You don't want to be part of you just want to build stuff like dApps, right? Learn smart contract language like Solidity and start doing for stuff on Ethereum and Ethereum entire ecosystem, right? If you are the type that are not into coding and you are into community building, and that's something you can, if you, one of these network solution piques your interest, build a community around it, right? Those are ways you can get involved, right? We have developer experience, there's a thing about when you have codes and you have people that can actually write code, but is writing it easy for them, making it easier for them to get involved. The barrier of getting into development, right? This is the job of what developer experience is all about, right? And bringing the familiarity more and more to developers, right? So these are ways you can get involved. User experience design. Like I said, some of these like DeFi applications are still quite far behind, so yeah, these are ways you can also get involved. And if you are like some very nerdy guy and you're like, you know what, I want to see how everything is done already good. Oh, welcome. You have something like protocol development there for you. You can get, neck deep into this kind of solution development, and believe you me, yeah, you will be part of those that are making Web3 evolve to the next phase of, probably even become the status quo of what we know of the Web, like Web 2.0 is right now. Right? So, yeah, next slide, please. So, yeah, you might be wondering, okay, all right, you've mentioned how we can get involved. Okay. So, how do I even start? So, there are stuff where you can learn for free. I've created like a few here. Build Space is one, right? You can pick up any. They have like several tutorials and their tutorials are in a way gamified for you to like pick up. They have different blockchain solutions there. They walk you through it. You join their Discord server. If you need help, you can raise questions there. They are all about community building and helping there. I can tell you for a fact that if you are into that, if you like that part of learning, you will really enjoy your time, right? Another one is Figment. Figment is a text-based, tutorial text-based, right? So you have set of tutorials of different. You have, I think, as far as I know, almost if not 10 to 12 different blockchains that you can build on, and they have like different tutorials on how to get started, how to even do some sophisticated stuff on it. They are all there for you. And if you are the type that, okay, yeah, I'm not interested in writing code per se, but I've been hearing of NFT, and this thing interests me. I have some things I think Petro as an NFT will become, the new, crypto punk kind of NFT. So there's something we have OpenSea. I'm sorry, I missed that out of there. You can list Solana, right? Built on Solana blockchain, and what it does is, think of Shopify for e-commerce, right? Metaplex does that for you right out of the box. You can easily just spin up your own NFT marketplace, like in one weekend, and start putting your NFTs there, and yeah, you own an NFT marketplace. Woo, welcome to Web3. So yeah, next slide. So in summary, what we've said all along about Web 1.0 and Web 2 has been pretty much, we can think of it as Internet of Information. We can pass information around, we can reach as far as the Earth goes, the world goes. Who knows? You could probably even reach those in Mars. You never know. Um, so, and you can think of it as Internet of Information, right? And Web 3.0 brings about Internet of Value. You could send Bitcoin to some guy in no man's land, and you receive it as quick as the blockchain can process it, right? And yeah, that's it. Welcome to Web3. I welcome you all to Web3. I hope you've all had like a good time. So, questions. Questions. Okay. Looks like I did a great job. There are no questions from me.
Hey, Dami.
Hi, Kusano.
There's actually quite a few questions on the Q&A channel. I think Shoma will read them out for us. Right, Shoma?
Okay. Please, I'm finding that. I can't seem to see Q&A here. Choma, would you read it out?
Okay, I think we were struggling. Maybe Choma can hear us. So the first question is, can we say the public blockchain is like an open source structure?
Yes, absolutely. So in fact, the idea of it is to be open source.
Is to open source all the applications or the what is it? Is this being open sourced here? Is it the infrastructure of the blockchain?
Oh, okay. So the idea of blockchain being open source is, anyone, like you said, we said it's open and anyone could just go and both on the on chain, that in the blockchain itself, you could go verify some transaction, as well as code level where you could go verify. Okay, this figure looks kind of sketchy. It might not be sketchy just because you didn't understand how it does. You could literally just pull their code down and then look for why it is done that way, right? And if you feel like something is still wrong there, you can propose a change.